Hi students, welcome to the science class. In last session under the chapter of metals and non-metals, we discussed about how the metals and non-metals reacts with acids and bases, and also what is meant by the reactivity series, how the most reacted metals reacts with the acids and bases, and what are the bases we are going to take we are going to write the reactivity series, and also we discuss some of the important types of the reactions, that is how the metals reacts with the solutions of the other metallic solution, isn't it? And also we discussed about displacement reaction. In today's session we are going to discuss how the metals can be extracted. In last session we discussed about where we are going to get the metals, from which material we are going to get the metal, that is we are going to get the metal by the metallic ores, we are going to get the metals by the minerals, we are going to get the specialized the definite metal from the definite metallic ore, isn't it? And we know what is ore and what is mineral in last session. So in today's section we are going to discuss how we are going to extract the metal from their metallic ore, respective metallic ores, and that can be studied under the chapter of metals and non-metals. So I am starts with the extraction of metals from ores. So already we know that the metals can be listed based on the reactivity series in the decreasing order, isn't it? Based on that reactivity series, we are going to classify the extraction of metals into three forms, that is the extraction of the metals of high reactive metals, and the extraction of the metals of medium reactive metals, and the extraction of the metals of low reactive metals. So by the help of the reactivity series, that is reactivity series, we are going to differentiate the extraction of metals into three forms. First I am considering here metals of the high reactivity, how we are going to extract the metals which are more reactive in nature. So as we know already, the metals of high reactivity in the reactivity series, some of the metals comes in the high reactivity series, that are nothing but sodium, potassium, calcium, magnesium and aluminum. These are found at the top of the reactivity series because they are most reactive. So how we are going to extract these metals from their respective ores? See, these metals, as we know already, these metals are very reactive in nature, therefore they are not freely available in the nature, they are not present in the free state in the nature. But how we are going to extract? They never found in the nature as free elements, they are found in the form of compounds. But how they are found in the nature? They are found in the nature as compounds, but these type of the metals are going to be extracted by the process called electrolysis. So these high reactivity series metals, for example sodium, potassium, calcium, magnesium, these are present in the nature in the form of compounds. Why? Because if they are present in the free form, they are going to easily react with the oxygen, easily react with the water which is present in the air, isn't it? They are very highly reactive with the oxygen, as we already, the sodium and potassium, these are very reactive, these are very reactive with the oxygen and water, isn't it? So therefore they are not found in the free state in the nature, but they are present in the nature in the form of the compounds. Is it clear? They are found in the form of the compounds. But how we are going to extract these elements? We are going to extract these elements by the process called electrolysis. What is electrolysis process? How we are going to extract these metals from the electrolysis process? That I will discuss here. In the electrolysis process, we are going to take the molten compound of these metals. The molten compound of these metals, we are going to take the metal ore in the form of the molten state, and through the molten state we are going to through the molten compound we are going to pass the electricity. The electricity is passed through the molten chlorides. We are going to take these elements as its chlorides, molten chlorides, and that molten chloride will be taken into a tumbler, and through this tumbler we are going to place two rods here, that is cathode and anode. Through this we are going to pass the electricity. What happens here when we are going to pass the electricity through the molten chloride? the metals which are present in the compound are deposited at the cathode, and the chlorides which are present in the compounds are deposited at the anode. That is nothing but the electrolysis. In the first chapter you have already studied about what is electrolysis. The process of extraction of the some of the metals by using electricity, it is known as the electrolysis process. So in this process we are going to pass the electricity in the molten chlorides, so the metals which are present in the metal chlorides that are deposited at the cathode, and the chloride which is present at the compound that will be deposited at the anode. So by removing the metals which are deposited at the cathode, we can easily get the metals which we are want. So this is the step of the extraction of these high reactive metals. Is it clear? So these high reactive metals are extracted by the process called electrolysis. And now I am considering the second step, that is the second type of the metals that are medium reactive. These are come at the middle part of the reactivity series. That metals are nothing but zinc, ferrous, isn't it? The metals of medium reactive, for example zinc, ferrous and lead. So these metals are usually present in the nature in the form of sulfide or a carbonate. See here, so in the first case these are very reactive in nature, therefore they are not present in the nature in a free state. They are present in the compounds, isn't it? They are present in the form of compounds. But when we are going to take the metals of the medium reactive, they are present in the form, usually they are present in the form of sulfide ores or the carbonate ores. These are medium reactive in nature, therefore they are present in the form of sulfide ores or a carbonate ores. So but it is clear that it is very easy to extract the metal from oxide ores rather than the sulfide ores or a carbonate ores. You have to remember here, you have to clearly observe here, it is very easy to extract from the metal from the oxide source. From the oxide source it is very easy to extract the metals, but it is very difficult to extract the metals from the sulfides ore and the carbonate ores. But these metals, the medium reactive metals, are present in the form of carbonate ores or a sulfide ore. So in the first step we are going to convert these sulfide ores and the carbonate ores in the form of oxide ores. Is it clear? So why? Because it is very easy to convert the oxides, or it is very easy to extract the metals from oxide ore. So therefore we are going to convert the sulfide ores into oxide ore and carbonate ores into oxide ore. How we are going to convert the carbonate ores into oxides? See here, the carbonate ores are heated strongly in limited presence of air. So we need to convert the carbonate ores into oxide ore. Why? Because it is very easy to get the metals from the oxide ore. So how we are going to convert the carbonate ores into oxide ore? The carbonate ores are heated strongly in limited presence of air to get oxide. So to get the oxide ore, we are going to heat the carbonate ores in a limited presence of air. We are going to heat, carbonate ores are heated strongly in a limited presence of air. In a limited presence of air to get the oxides, and this process is known as a calcination. You have to remember here, in your examination 2 marks question should be asked, what is the calcination? Give an example. So the calcination is nothing but it is a process of conversion of carbonate ores into oxide ores. How it is? What is this process? The carbonate ores are heated in a limited presence of air to get the oxides. So this process is known as a calcination. For example, I am considering the one of the medium reactive metal, that is zinc. So I am considering we are having the ore as a carbonate ore, that is zinc carbonate. So this zinc carbonate, it is heated in a limited presence of air, we get a zinc oxide. We get zinc oxide and carbon dioxide is released. So we get now the zinc oxide. Why we need to convert the zinc carbonate ore into zinc oxide? Because it is very easy to get it is very easy to extract the metal from oxide ore. Now I am considering the sulfide ore. If the metal it is present in the form of sulfide ore, how we are going to convert that sulfide ore into an oxide ore? The sulfide ores are converted into oxides by heating strongly in the presence of excess of air, and this process is known as roasting. You have to remember here, the carbonate ores are heated in a limited presence of air, and this process is called it as that is calcination. But the sulfide ores are heated in the presence of excess of air, and this process is known as roasting. So the sulfide ores are converted into oxides by heating strongly in the presence of excess of air. Excess of air means the external air, so we are going to provide the external air here. So this process is known as roasting in our examination. So they are going to ask simultaneously what is calcination and what is roasting for 2 marks question. You have to remember these are most important here, very easy definitions, and we can get a very easy marks here. So what is roasting? Sulfide ores are converted into oxides by heating strongly in the presence of excess of air, and this process is known as roasting. So I am taking another same example here. If the zinc ore it is present in the form of zinc sulfide, that zinc sulfide is mixed with, that is will be heated in the presence of excess of air, that is 3O2 oxygen. The zinc sulfide is heated strongly in the presence of excess of air. We get here again the zinc oxide. It is very necessary to convert the sulfide ores into the oxide ore, because it is very easy to extract the metals from oxide ore rather than the carbonate ores and sulfide ores. So now we get the oxide ore. In the first case we get zinc oxide from the carbonate ore, and also in second case we get the zinc oxide from the sulfide ores. Now how we are going to get the pure metal from the zinc oxide? These metal oxides are treated with the suitable reducing agents and we get pure metal. So these oxides, these metallic oxides are going to be treated with the suitable reducing agents and we get the pure metal here. So I am taking one example here. This zinc oxide will be treated with the carbon and we get the zinc, pure zinc metal with the releasing of carbon. The carbon monoxide will be released and we get pure zinc metal. So this is all over the process how we are going to extract the medium reactive metal. So you have to remember 2 points very important here. First one, it is a calcination, and second one, it is that is the roasting. So in your examination 2 to 3 marks questions should be asked on this. Write the process of extraction of metals with a medium reactive, or they are going to give 5 marks questions on basis of all three methods, that is metals of high reactivity, metals of medium reactivity. You all already know how we are going to extract the metals of high reactivity. They are going to be extracted by the process of electrolysis, and the medium reactive metals are going to be extracted by the help of the calcination process and the roasting process. Is it clear? Now the extraction of metals of low reactivity. So as we know already, the metals with a low reactivity, they are present in the nature in the form of oxides. Why? Because the nature of these metals is a low reactive, so they are present in the form of the oxide. So as we know already, it is very easy to extract the metals from the oxide ores. So these low reactive metals, for example the gold, silver and the mercury, these are present in the nature in the form of oxide ores. So these oxides ore are going to be treated with the suitable reducing agents and we get the pure metal. So the low reactive metals which are present in the nature, they are present in the form of oxides. So extraction of these metals from this oxide ore, it is very easy. So as we know already, the oxide ores are going to be treated with a suitable reducing agent to get the pure metal. For example, the mercury is heated, then it is very easy to get the mercury from the oxide ore. When we are going to heat the mercury, we get the separate mercury and the oxygen will be released. So therefore the metals with a low reactive which are present in the nature, they are present in the form of oxide ore. It is very easy to get the metals from oxide ore. So but as we get the metals from all the three types here. So metals with a high reactivity series, the metals with a low reactivity, and the metals with a medium reactive. What the metals which we are getting these extraction process, something the metals, these metals are not completely pure metals. The metals which we are get here, they are not pure, they are not in pure form. Some some of the impurities or the improper dust will be present in that metals. How we are going to remove that impure metals or impurities from that pure metal? By the help of the electrolytic refining. By the help of the electrolytic refining process, we are going to remove the impurities present in the metals which we are get from all these processes. So in the electrolytic refining, we are going to pass the electricity through the electrolyte. The electrolyte, it is nothing but same in the as we did in the electrolysis. The electrolyte, it is contains of the molten given metals or molten given impurities, that is nothing but the electrolyte. So through when we are going to pass the current through the molten electrolyte, the impurities which are present in the electrolyte are deposited at the bottom of the tumbler, and the pure metal which is present in the electrolyte, it is deposited at the cathode. So by removing the metal which is present at, which is deposited at the cathode, we are going to get very pure metal by the electrolytic refining. So this is all about how we are going to get the pure metal, or how we are going to extract the metals from their respective ores. Is it clear? So next I am considering here, so when you are going to left the metals in the air, so as we know already, metals always reacts with the air and moisture. So well, I am taking one example here. If you are going to place the iron rod for the moist air for the long time, what happen here? The brownish, red brownish colored will be appearing on the iron. So what it is, what is the reaction here? So it is nothing but the corrosion. When the metals are exposed to the moist air for the sometimes they react with the moist air and that will be corroded, and this process is known as a corrosion. What is corrosion? When metals exposed to the moist air for long time, it reacts with the air and metal can be corroded. And this process is known as corrosion. So when any metal exposes to the air, moist air, as we know already, metals reacts with oxygen, metals reacts with the water. So when you are going to expose the metals with the air for the long time, what happens here? The oxygen which is present in the moist air will be reacts with the metal and form a thin coated layer black. It is a brownish color or it is a black color, that is nothing but, that process is nothing but the corrosion. So when it is comes, when the layer of the brownish color layer comes on the metals, then we are going to call it as the metal will be corroded, and this process is known as the corrosion. So when the corrosion happens to any metals, it will be decreases its activity and it will be decreases its lifetime or a life period. So how we are going to prevent this corrosion? For example, we are using some of the iron rods for to prepare or for to construct our houses or homes. If the rods are corroded, what happens here? The lifespan of that iron rod will be decreases due to the corrosion. But how we are going to prevent the corrosion? For example, when you are going to buy some of the iron rods from the shops, from the enterprises, so they are going to have the large amount of the iron rods in their shops. But if they are going to keep that iron rods for a few times, for a long days, long periods of times, what happens there in that iron rods, they can be get corroded. If they can get corroded, the lifespan of that iron materials will be decreased. So what they are going to do, what they are going to take the precautions to prevent the corrosion. So that what are the preventions taken to prevent the corrosion here? The rusting of the iron can be prevented by painting, oiling, greasing, galvanizing and making ollies. See here how we are going to prevent the corrosion of the metals. We are going to prevent the corrosion of the metals by painting, oiling. If you are going to see the metals which are present in the shops, they are going to paint some color, some light colors. They are going to paint some of the paints on the iron rods. They are not necessary, but they are also paint some of the paints at the ends or at the some parts of the metals. Why? Because to prevent the corrosion, to prevent that metals from the corrosion, they are going to use painting here. So some of the steps to prevent the corrosion are painting, oiling, greasing, galvanizing and making ollies. By the making of the ollies, what are ollies? Ollies are the homogeneous mixture of metals and non-metals. For example, steel, it is not a pure form of the iron metal here. So we are going to mix the metals with the non-metals or other metals, then we get the ollies. What is ollies? Ollies are the homogeneous mixtures of the metals and non-metals. These ollies are not corroded by easily. They are not react with the oxygen, they are not react with the water, therefore they are not corroded here. So we are going to make the ollies of that metals to prevent that corrosion. So what are the example for the ollies here? The steel is a mixture of iron, nickel and a chromium. Steel is a mixture of iron, nickel and a chromium. The steel metal, it is made up by the three metals called iron, nickel and a chromium. And a brass, the brass is a mixture of two metals that is called as one is a copper, another one is a zinc. This is an ollie. Brass is also one of the ollie that is made by the homogeneous mixture of copper and the zinc. And the bronze is the mixture of copper and the tin. It is also a mixture of the two metals, that is nothing but copper and the tin. And the solder, so when you are going to see in the some of the repairing shops, they are going to use the metallic wire to solder some of the things. So that solder wire will be made by the lead, mixture of lead and tin. So it is one of the ollie here. And the amalgam, it is a mixture of any metal with the mercury. It is another one type of the ollie. These are all examples for the ollies. Is it clear? So why we are going to make the ollies here? Because to increase the lifespan and also to prevent the metals from the corrosion, we are going to make its ollies. Is it clear? So in our homes, in older days, we have the bronze metals or the bronze materials in our home. Why? Because they know that if we are going to use only copper metals, as we know already, the copper metals are going to be reacted with the acids which are present in the foods. For example, if you are going to put the curd or some of the juices, that is gastric juices or acidic juices in the copper, it is easily react with that acids which are present in the food items. Therefore they are going to, in our ancestors, they are going to make the ollies of that copper metal to make the materials which are helpful to use in our home. Therefore we have the some of the ollie materials, that is bronze, that is one of the ollie which is made by the two metals that is called it as a copper and a tin. So these are very helpful, the ollies which why we are going to make the ollies here, to increase the lifespan of the metal and also to prevent the reaction of that metals with the acids which are present in the food items. Is it clear? And another one method here to prevent the corrosion, it is nothing but the galvanization. What is galvanization here? It is a process of prevention of the corrosion of the metals by coating a zinc layer on the metals. That is known as the galvanization. The process of prevention of the metals by making a zinc coat on the metals, that is known as a galvanization. So these are the important steps, these are the important process which we are going to use to prevent the corrosion But what are those? That is painting, oiling, greasing, galvanization and making Ollies. And this completes your another one important lesson, metals and non-metals. So in this lesson we discuss what are the uses of the metals, how we are going to make the Ollies, what are the uses of the non-metals, and also how the metals and non-metals react with the acids, bases, and also we discussed here the physical and chemical properties of the metals and non-metals. So in next session, we are going to continue our next lesson, that is nothing but the magnetic effect of electric current. So we can see in your next class. Thank you.